To solve a rational equation, you need to multiply every term by the least common denominator. What that will do is clear out your fractions and give you a nice equation to solve. Let's take a look at this first one. On the first one, I think it's a good idea to put that as a 1 underneath that other 1 so that you can kind of think of every one in terms of a fraction. So you're going to look at your denominators, a 1, a 3, and an 11, and you've got to decide what is the common denominator. What is a number that all of those will go into? So 33 is the number that 11, 3, and 1 go into. Then you're going to multiply that times every single term. Then you cancel. And note, this is a 33 in the numerator, which allows that 11 in the denominator to go into that 33 in the numerator 3 times. Nothing cancels here, and here 3 goes into 33 11 times. Then you're going to take what you have and let's distribute. So when I distribute that, that is going to give me 21x minus 6, then minus 33 times 1 equals, and over here we're also going to distribute that 11 through, giving us 22x minus 77. Collect your like terms. 21x minus 39 is equal to 22x minus 77. Then I will solve the equation. I like to do my variables first, so I'm going to subtract the 21x over. That gives me negative 39 equals x minus 77. Add your 77 over, and you get your answer of x equals 38. All right, let's take a look at example 2. If you would like to, you could pause the video and try the problem on your own, and then restart the video and check your work with me. So we need to find a common denominator. So look at all your denominators. You have an x plus 3, a 2, and a 10. So we need to find a denominator that all of those will go into. We know pretty easily that the 10 and the 2 both go into 10. So 10 will be able to handle those two items. But we also need for an x plus 3 to go into it. So we need an x plus 3. When you're getting a common denominator, your denominator has got to be able to accommodate or handle each of those individual denominators. They all have to be able to go back into it. So now we're going to multiply every single term by 10 and an x plus 3, a 10 and an x plus 3. Cancel what you can. That we see the x plus 3's cancel with the x plus 3's. 2 goes into 10 5 times, and the 10's completely cancel. All right, let's see what we're left with. You have a 10 times a 2, which is 20, plus you have 3 times 5 times x plus 3. So that gives me 15 times x plus 3. Equals, and then you have 19 times x plus 3. So I'm going to solve the equation. 20 plus, distribute your 15. 15x plus 45 is equal to 19x plus 57. All right, collect your like terms. So that's going to give me 15x plus 65 is equal to 19x plus 57. Again, I like to put the variables together first. So I'm going to choose to subtract the 15 from both sides. That brings down 65 is equal to 4x plus 57. We're going to subtract the 57 from both sides. And when I do that, that's going to give me 8 is equal to 4x dividing by 4, and x is equal to 2. Okay, let's look at problem number 3. On problem number 3, the first thing we're going to do is we're going to look at our denominators, see what we've got, so that we know what we need to be able to handle or to accommodate. So I know that I've got to pick something that a 3 will go into, an x will go into, and the group x minus 2 will go into. This 3 is already taken care of because of that 3. So I need to have a 3, I need to have an x, and I need to have the group x minus 2. So we're going to multiply that by every single person. So 3x and an x minus 2, 3x and an x minus 2, 3x and an x minus 2. Cancel everything that you can. Those cancel. Your x minus 2's cancel. And your 3 cancels. Right? Let's see what we're left with. We have an x minus 2 and an x plus 2. So x minus 2 and x plus 2. Here we have a 3x and an x plus 4. So 3x and x plus 4. And here we have a 2, an x, and an x minus 2. So 2x and x minus 2. All right, let's go ahead and solve the equation. Right here, you are going to distribute or FOIL. It's the same thing. That x is going to distribute to everyone, be in your first and your outers. Then this negative 2 says, okay, now it's my turn to distribute through everybody, which gets your insides and your last. So that would give me x squared plus 2x minus 2x minus 4 equals, distribute your 3x through. 3x times x is 3x squared, plus 3x times 4 is 12x. Now right here, I'm going to draw my red warning flag. That's telling me to be very careful with my signs, because that negative has to go through to everybody. So negative 2x times x is negative 2x squared. Negative 2x times negative 2 is positive 4x. All right, let's collect our like terms. So that's going to give me x squared, those cancel, minus 4 is equal to 3x squared minus 2x squared is x squared, and 12 plus 4 gives me 16x. All right, we're going to subtract our x squareds from both sides, and they cancel, which leaves me with negative 4 is equal to 16x. Now, on this right here, be careful, because our instinct is to want to just say, oh, 4 goes into 16, and my answer is negative 4. But recall, when you're solving an equation, you have to solve for the variable. That means in reality, I have to divide by the 16. And then my answer becomes, reduce that fraction, negative 1 over 4. Okay, let's take a look at example 4, problem 4. All right, again, if you'd like to, pause the video and try it on your own and then restart it. So look at your denominators. So our denominators are a 6x plus 7 and a 2x plus 9. So the denominator that I need that both of those will go into is a 6x plus 7 group and a 2x plus 9 group. I'm going to multiply that to both sides, 6x plus 7 and 2x plus 9, 6x plus 7 and 2x plus 9. I see that the 6x plus 7's cancel. I see over here the 2x plus 9's cancel. So then what I'm left with is a 10 and a 2x plus 9. 10 and 2x plus 9. Over here, I'm left with a 6 and a 6x plus 7. Distribute your 10 through to get 20x plus 90. Distribute your 6 to get 36x plus 42. Then I'm going to solve the equation. I'm going to choose to subtract my x's first by bringing that 20 over. So I have 90 is equal to 16x plus 42. Subtract your 42 over, and I get 48 is equal to 16x. Divide by 16, and x is equal to 3. Now, there's another way that this can be solved. Many of you guys may have heard of the cross multiply method, and that's true. You can do that. So let me show you what you could have done. Cross multiply only works if you have a single fraction equals a single fraction. And you do exactly what it says. You're going to cross multiply those to each other. So that means that this one multiplies to this one, they're across from each other. This one multiplies to this one, they're across from each other. So the 10 is across from the 2x plus 9. The 6 is across from the 6x plus 7. And you can see that's exactly what we got as well. Okay, let's take a look at problem number 5. Again, pause the video if you would like. So we need to look at our denominators, and we need to find a common denominator, a denominator that each of those will go into. But before I do that, I need to see what I actually have here. This x squared minus 3x needs to be simplified. It needs to be factored. You can take a greatest common factor out of that. And so you have x with an x minus 3. And I'm going to lightly kind of swish through that. Then I have an x minus 3. And then I just have an x. So the things that I need for these denominators to go into are an x and an x minus 3. Recall, when you're picking a common denominator, when you're choosing one, you have to make sure that your denominator will be able to handle all of the pieces over there. So I'm going to multiply by x and x minus 3, multiply by x and x minus 3, x and x minus 3. All right, let's see what all will cancel. So I see that my x's cancel. My x minus 3's cancel. Here my x minus 3's cancel. And here my x's cancel. Let's see what we're left with. We're left with just 18 minus 6x is equal to 5 times x minus 3. So bring down your 18 minus 6x. Distribute your 5 and get 5x minus 15. I'm going to get my x terms together by adding 6x to both sides. So that gives me 18 is equal to 11x minus 15. Add your 15 to the other side. 33 is equal to 11x. Divide by 11, and x is equal to 3. Now, there is something that you have to do with these rational equations. You have to take your answer and make sure that it can check back into the original equation. Whenever you're multiplying an equation by a variable like we are here, we're multiplying by just x's unknown, so to speak, it's possible to get a solution that really doesn't check. So this x should be able to go into the original equation anywhere there's an x. If we were to put that x right there, if we were to let that x go live in his house right there, do you see that we would have 3 minus 3, which is 0 in a denominator? And in mathematics, we can't have zeros in the denominator. That makes you undefined. So if x were 3, this equation wouldn't be defined. So therefore, you have to throw that answer out, and there would be no solution to this particular question. All right, let's take a look at example 5. All right, on number 5, we need to look at those denominators and see what we got. So we have an x minus 3, we have an x plus 2, and then we have this trinomial that needs to be factored so that we can see what we really have there. All right, so we've got an x minus 3. This trinomial gets factored. When you factor a trinomial, it's what multiplies to get the first one, x times x. What multiplies to get 6, but adds to get 1 would be a 3 and a 2. But look at your middleman. He's negative, so we need the negatives to win. So negative 3 and plus 2. And then you have an x plus 2. All right, so the common denominator I need is an x minus 3 and an x plus 2. Multiply that by every single person, x minus 3, x plus 2, x minus 3, x plus 2, x minus 3, x plus 2. Cancel the things that you can. The x minus 3's cancel. They both cancel this time, and your x plus 2's are going to cancel. Let's see what we're left with. This right here is an x and an x plus 2. Here we have this right there, which is plus negative 7x plus 6. Here you have a 2 and an x minus 3. Solve this equation by distributing your x through to get x squared plus 2x, and then bring this down, and then distribute your 2, and you get 2x minus 6. Collect your like terms, so x squared minus 5x plus 6 is equal to 2x minus 6. When you're solving an equation that has a squared term or a quadratic, you have to set it equal to 0 and then try to factor. So I'm going to subtract the 2x, come over here and find his friends, subtract 2x. You're going to add 6, come over here and find his friend. So I have 0 on this side. And over here I have x squared minus 7x plus 12. And that's going to be a nice trinomial that we can factor again. So we're going to multiply to get x squared, which is x and x. Multiply to get 12, but add to get 7, which is 3 and 4. Now look at your middleman. That's a negative 7. So we need negative 3 and negative 4 in order to get that. Now you're going to set each factor equal to 0. And x is equal to 3 and x is equal to 4. But you'll recall that we said in that last problem that we need to do a spot check, just a real quick little check to make sure that the answers you got don't make my equation undefined. And if I put a 3 in right here, because he could go live in that house right there, that's his house where an X is, and if I put a 3 right there, I'll have 3 minus 3, once again giving me a 0 in a denominator. So this answer you have to throw out, but this answer will work. The only other thing that would have messed us up, if we had had a negative 2, then that answer we would have had to throw out as well. But that wasn't the case. All right, let's take a look at number 7. Again, if you would like to, pause the video, try it on your own, and see how you do. All right, so let's see what denominators we have in this one. We have an x plus 2, we have an x minus 2, and an x squared minus 4. However, that x squared minus 4 needs to be factored so that we can truly see what it is. That is a difference of two squares, x and x. And then multiplying to get 4 is 2 and 2. But notice you don't have anyone in the middle there. So that's because they canceled with a plus and a minus 2. And then we'll switch through. All right, then my common denominator is x plus 2 and x minus 2. That's what I need for each of those individual terms to go into the denominator. We will multiply by an x plus 2 and an x minus 2 to u, an x plus 2 and an x minus 2 to u, and an x plus 2 and an x minus 2 to u. All right, let's cancel what we can. The x plus 2's will cancel. The x minus 2's will cancel. And here, they both cancel. All right, let's see what we're left with. We've got an x minus 2 for that part, plus we have an x plus 5 and an x plus 2. So x plus 5, x plus 2 is equal to 1. All right, let's solve the equation. Bring down your x minus 2. Right here, you're either going to distribute or FOIL, whichever one you call that. It's the same thing. I like to distribute. The x is going to distribute through to everybody. And then the 5 says, okay, now it's my turn to distribute to everybody. And so that's going to give me x times x, which is x squared, plus x times 2 is 2x, plus 5 times x, plus 5 times 2 is 10, is equal to 1. All right, collect your like terms. I have an x squared. Then I have an x, a 2x, and a 5x. That's going to give me 8x. And then my numbers, I have a negative 2 and a positive 10, which is a positive 8, is equal to 1. All right, because this is a quadratic or a second degree equation, we need to set it equal to 0 and try to factor. So subtract your 1 over, come over here and find his friend, his like term, and I have x squared plus 8x plus 7 is equal to 0. That's another trinomial that can be pretty easily factored. So I'm going to multiply to get x squared, which is x and x. I'm going to multiply to get 7, but add to get 8, which would be 7 plus 1. Set each factor equal to 0. And that means that I have, we'll come over here, x is equal to negative 7 and x is equal to negative 1. Let's do a spot check just to make sure that that doesn't make my equation undefined. So I look in the denominators because that's the place where if I get a 0, it's going to mess us up. The only thing that would mess this equation up is a negative 2 plus 2 or a positive 2 minus 2. But I don't have either one of those situations. So both of those answers are going to check. Okay, last one. You guys are doing great. So let's take a look at our denominators and see what we've got. We have x plus 4's, x plus 1's. So the common denominator that we need so that each of those will go into our denominator are x plus 4's and x plus 1's. So we're going to multiply every single person by an x plus 4 and an x plus 1, an x plus 4 and an x plus 1, an x plus 4 and an x plus 1. Cancel everything that you can. X plus 4's are gone, x plus 1's are gone, x plus 1's are gone again. All right, let's see what we're left with. We have a 5 and an x plus 1. We have a 2x plus 1 and an x plus 4 that we'll get to do some distributing on. and we have an x and an x plus 4. All right, let's solve it. Distribute your 5 through and get 5x plus 5. Plus, distribute here, 2x goes to everybody, 2x squared, plus 8x. And then the 1 says, okay, now my turn. 1 times x is 1x, and 1 times 4 is 4. And this x distributes, and you get x squared plus 4x. All right, collect your like terms, and that's going to give me 2x squared. 5 plus 8 plus 1 is going to be 14x, and 5 plus 4 is going to give me 9, equals x squared plus 4x. All right, because that's a quadratic or a second degree equation, we need to set this equal to 0 and factor. If for some reason it wouldn't factor, then you would have to pull out your friend the quadratic formula. So we're going to subtract x squared, go find his friend, subtract 4x, go find his friend. So I have 0 equals x squared plus 10x plus 9. A nice trinomial to factor. X and x is what multiplies to get me x squared. 9 and 1, that's what multiplies to get 9, but adds to get 10. Set each one equal to 0. And x equals -9, and x equals -1. Let's do a spot check. We got to make sure we can keep those. And if you look closely, that -1 is not going to work, because -1 living right there means -1 plus 1 to get a 0. So throw him away and keep that one. If this video was helpful, please like and subscribe to my channel. This allows me to continue to grow the channel so I can help build your math esteem one problem at a time. See you later.